Hello, exceptional students of Mrs. Whitney's. Welcome to section 5.2e, graphing proportional relationships. So remember, you can take values from a ratio table and use them as xy coordinates to graph on a graph. So this ratio table is time is x, and there's seconds, and that column corresponds to the x-axis, and height is in meters, and that corresponds to the y-axis. So these make nice, lovely little xy pairs. Like, oops, I'm drawing. We got like little xy pairs, and I can plot each of these and create a table. Create a graph. And if I connect those, I get this lovely straight line that goes through the origin. So the structure in a ratio table shows why the graph has a constant rate of change. And you know it's a constant rate of change because it goes through the origin and is a straight line. So the graph of every proportional relationship is a line through the origin. Remember, straight line is redundant. If it's a line, it's straight. So let's determine whether or not two quantities are proportional. So I'm going to plot these, and I'm going to use these as xy pairs. So we will have 2, 6, and 4, y, and 6, 10. So 2, 6, so go over it. So remember, it's always the x and y pair. So the first number is always x, and the x-axis is always going horizontal, and the y-axis is always going vertical. So we have 2, 6. So we go over 2, and then we go up 6, and we plot a dot. And then 4, 8. So I go over 4 and up to 8. And then 6 and up to 10. And, oops, nope, right here. And I'm going to try to use a straight line. Can I make a straight line? I can. So if I take a line and connect the dots and extend it, notice it is a straight line, or a line, but it does not go through the origin. So it doesn't cross, oops, let me get out of making lines. So it does not go through the origin, so therefore it is not a proportional relationship, so no. I'm going to go over here and create xy pairs here. So it's 1, 2, 2, 4, and 3, 6. So if I plot those, I go over 1 and up 2. That's Brita, she's charming. Go over 2 and go up 4. And go over 3 and go up 6. And now when I grab that line and connect everybody, you'll see that it does indeed. It is a line and it goes through the origin. So yes, it is a proportional relationship. It would be lovely if I was actually drawing. So yes, it is a proportional relationship. All right. Interpreting the graph of a proportional relationship. So the graph shows the distance traveled by the Mars rover Curiosity is proportional to the time traveled. Interpret each plotted point on the graph. So all this is really saying is that I take 0, 0, and 0, 0. I have 3 plots, right? 0, 0, 1, and 1 and 5 tenths, and 3, and 4, and 5 tenths. All it's really asking me is, what do those dots mean? Well, remember, it's x and y, and x is the x-axis, and y is the y-axis. So this means we have 0 seconds, and we've gone 0 inches. Kind of makes sense. 1, this means 1 second, and 1 inch. And then 3 is 3 seconds, and 4 and 5 tenths inches. So if it says to interpret, all it really means is tell me what each dot means. All right, we can also find the unit rate. And the unit rate is, in a proportional relationship, we can calculate the unit rate is equal to the ratio of y over x. So I can take any point y on the graph and any over the corresponding y point. So I'm going to choose this one right here, where y is 40 and x is 2. So I'm going to say that x is 2, so that goes in the denominator, and y is 40. And we're talking about chairs and rows. So if it's a unit rate, it means the denominator is 1. So I'm going to simplify that to be, for every row, there are 20 chairs. Thanks for watching.